Okay. So that is the basic difference. Whenever you configure the data path for brokers, it will be log.dir. And similarly, for Zookeeper, it will be data.dir. Can you go to the zookeeper.properties? Yeah, this one. And can you go to any of the server.properties? Yeah. Basically, whatever we are saying here, log, that log is nothing but data. Because in Zookeeper, in case of broker, logs are nothing but your data. So that is why we are saying it log.dir.
Okay.
So whenever you will send any data to the topic, and the topic has partitions, and the data will go inside the partition. So basically that data is going to be stored in this directory which we have configured here using log.dirs d colon Kafka logs broker1. Okay, and can you go to the zookeeper.properties? Now all the cluster information Zookeeper will store inside data.dir folder. How many brokers are there, and which is the leader partition for particular topic, and where are those leader partitions hosted, and that is the first thing, this information, and whenever consumer reads any data from the Kafka cluster, it should be knowing where exactly the current position of reading. So that offset will also be stored inside the Zookeeper, so that next time it can request the data, next data, right? And in case of any kind of failure in the Kafka cluster, next time when the consumer will start again reading again, then it will reach out to Zookeeper only to know where exactly it was reading from, and it will resume from that position. So offset related things are also stored here. Okay, so this is clear. I create the topics. Go to the bottom. I don't see any error. There is also no error. No error. Okay. So now we can create the topic. Now I will show you one more thing while creating the topic. Yeah. Here, where is the command? Just go back to the command. Yeah, this is your command. So till now we were writing Kafka topics create, and then we were saying bootstrap server localhost 9093. Now we can give one more bootstrap server name, localhost colon 9094, then space localhost 909 2. Okay, server name localhost colon 9094, then space localhost 909 2. Okay, because we have now 3 brokers. So in case we are not able to connect to 9093, we can connect to 9092 and 9094. So just you can give that those remaining broker IP addresses and port number here. Just try it. No. Bootstrap server we have already given. Just give the address. Topic name. Test replication is already there, or it is not created?
That's how we did it with like that folder.
So you can give some other name if test replication topic is already there. Okay. Hit enter. So now you saw the effect because we have provided the list. So even if it is not able to connect to 9093, it will go to 9092. If it is not able to connect to 9092 also, then it will try with 9094. Okay. So that list also you can give, though it is, again, it is not compulsory. Now what we will do is, let's make 9093 down. Okay, just go to the 9093 broker and just stop it, and then we will execute this command again, and let's see what happens. Oh, this is broker 2. Yes, this is 9092. Correct. Oh, this is broker 2. Yes, this is 9092. Correct. So you can say Control C. Yes, so your broker 2 is now gone. It is not in the cluster. Now you go to that command again and go to the, can you use arrow key to recall the previous command? Create command which we just now executed. Yes. Now, can you please give a different topic name here? Maybe Kafka replication 2, you can say. Now 9093 is down. Hit enter. So it says 9093 connection could not be established. Why it is not trying with 909? Okay, broker may not be available. Okay, can you give Control C? Good. Yeah, recall that command again. I'm just trying. Can you give comma instead of space? Comma instead of space. Yeah, enter. Okay. Yeah. So now the command would have worked, but because replication factor you have given 3 and the Kafka broker is down, so replication factor 3 cannot be achieved. So you can give 2, and now enter. Yeah. So you saw the effect. What happened? It was not able to connect to 9093, so it tried second broker in the list, and it was able to connect, and it created the topic, right? But obviously there are only 2 brokers left in the topic, so it will not be able to create the topic with the desired replication factor, you can create only a topic with the replication factor 2.
Yeah.
Right? So this command is also very useful. Just keep it handy that you can specify comma separated list of brokers also whenever you are creating the topic in a Kafka cluster. Okay.
Now the topic Kafka replication tool is created in which broker?
Sorry.
Kafka replication tool is created in which broker? Like 9092 or 9094?
Okay. So you can describe it. You will get all the information. Copy the name from somewhere. Don't need to type anything again and again. Previously, in the previous command, we had that name.
How to copy it?
Yeah, just right click. No, in the cursor position, just right click. Okay, here, just left right click, it will be copied. Yeah.
Okay.
Two times you have to right click, that's it, nothing else. Yeah, you can, you have to give here localhost 9092 or you can give 9094 also, not an issue. Now, your question was on which broker it will be created, that topic. So we know that topic is not part of any particular broker. Topic is distributed across all the brokers using partitions. Okay. So if your question is where the leader is stored for any particular partition, so that you can see. But obviously Kafka replication 2 topic will be created on all the brokers. Right? So you can see replication vector is 2 and then Kafka replication vector is 2 and then Kafka replication 2 topic. Partition 0 is on broker 2. I mean to say partition 0 is there on other brokers also, but the leader for partition 0 is on broker 2. Okay. And there are 2 replicas obviously because replication vector is 2. So replica, one replica is on broker 2 and one replica is on broker 0. Right? Because replicas are numbered as 0 like that. And similarly, insync replicas are also 2 and 0. Insync replicas, I'll explain you. It's a very small term. Normal thing. It's not a big thing. Normal thing. It's not a big thing. So similarly, I think yesterday I shared the PPT. In that I have explained in detail what is the meaning of the output of describe command. Have you gone through it?
Output of describe command. Yes, yeah, the partitions.
Yeah, what is the meaning of this entire column?
Yeah. We went through it.
Yeah. So you can easily understand. So now this is very much clear. Now let's, any other questions if you have, we can discuss, otherwise we'll go forward.
No, we can go forward.
Okay. Yeah, 9093 is down, you have to start 9093 again, then only you can list. Or you can use other broker if you want to list anything.
Okay, we can start.
Okay. And here also you can specify the comma separated list. It's not that only in the previous command you can give. Anywhere you can give the comma separated broker list wherever you are using Bootstrap server.
Okay.
Okay. Sometimes people use this broker list also instead of Bootstrap server. Can you try that command also? Hyphen list. Enter. Okay, it says broker list is not recognized option. Okay, it might not be available in this latest version. That's fine, not an issue. Leave it. Now let's go ahead. So first I will explain you what is insync replica, and then we will go ahead with other stuff.
Yeah.
I'm sharing my screen. Is my screen visible, Jagdish?
Yes, I can see your screen.
Okay. So we are going to start with Day-9. So what is insync replicas? ISR you have seen in the output. So ISR means insync replicas. So here you can see the insync replica is nothing but it is a replica that is up to date with the leader. Okay. So we know that whenever a partition is created, there will be a insync replica is nothing but it is a replica that is up to date with the leader. Okay. So we know that whenever a partition is created, there will be a leader and remaining are the follower. For each partition, there will be one leader and remaining followers. So suppose your replication factor is 4. Then one leader replica will be created and remaining will be the follower replicas. Okay. Together we will have definitely 4 replicas because leader is also called replica only. The leader is also a replica and followers are also replica. But obviously read write will be done only in leader partition and followers will simply keep looking at the leader partition and time to time they will update themselves. So obviously it is very important that outdated replicas. So that is the simple concept. Whatever total number of replicas are there, then if all are in sync, leader will always be in sync for sure, right? Because read write is happening directly to leader. But the followers should also be synchronized. So total number of, ideally if the cluster is working properly, then in sync replicas will be equal to the number of total partitions. Okay, so if I ask you, the replication factor of any topic is 4. Okay, and there are 3 partitions. How many insync replicas will be there for partition 0? How many insync replicas will be there for partition 0? 4, right? All the replicas are insync replicas only, including leader also. For partition 1 also, the insync replicas will be 4. Partition 2 also, insync replicas will be 4. Now, by any chance, if the broker on which your follower is running, that goes down. Okay. One of the brokers which is running your follower replica, that goes down, then definitely that particular broker is not in the network. Okay. And then in that case, what will happen is we will lose that particular replica. That particular replica will no more be in sync. So that is the whole idea of in sync replica, which we call ISR in short. Nothing special. So if you read this statement, an ISR is a replica that is up to date with the leader broker for a partition. Any replica that is not up to date with the leader is out of sync. Here you can see there are three brokers. We have given number like 101, 102, 103. Okay. And partition 0 is the leader partition for topic A. So there is a topic which we have created, name is topic A, and it has partition 0 and partition 1. There are two partitions of this topic. So partition 0 is on 101, which is the leader, and the follower of this partition will be on second broker. This is the one bottom. Yeah. So obviously this is ISR in sync broker. This is the one bottom. Yeah. So obviously this is ISR in sync replica, okay, of this topic. If we see together, all are both are in sync replicas, but basically this is the follower. So generally we call this as ISR. Okay. And similarly for partition 1, the leader is on broker 102 and its in sync replica, or you can say follower, is on broker 103. So that follower we are calling it ISR, but actually that is not correct thing. ISR will be total both the things, which you can see in the described topic output. If there are 3 partition, ISR will also be showing 3. If there are 10 partition, 3 partition, ISR will also be showing 3. If there are 10 partition, ISR will also be showing 10. Okay. So this is the whole idea, nothing else. Any questions?
No, sir.
Okay. This yellow star is nothing but it is showing that the leader is on this particular group. Leader partition, nothing else. So these two are leader partition. That's why we are showing star.
Okay.
Now, today we will be discussing something about the zookeeper cluster. How we can create a zookeeper cluster with more than one zookeeper. So till now the above part we are very clear. Left hand side is nothing but those are Kafka producers.
No.
Okay. Kafka producers will produce the data, that those data will go to the Kafka cluster, and then at the second means on the other side of this cluster we have consumers which will consume the data from the Kafka cluster. So this is fine. Now bottom side we can see there is a zookeeper. So basically zookeeper interacts with Kafka cluster and it interacts with consumers. Zookeeper hardly interacts with producer because producer will be sending data always to Kafka cluster. Okay, so in the they will get all the details, all the information from the Kafka cluster itself. They never reach to zookeeper. So you might have seen that whenever we start any producer, we will always specify the broker names. In start any producer, we will always specify the broker names in the list. Correct?
Yes.
So that is never required, but consumer will definitely need zookeeper because consumer need to know what was the exact offset which it has to read. Whenever it has to demand the data, it has to supply the offset to the zookeeper, and then the data will be provided to consumer. Offset 0, offset 1, offset 2, offset 3, like that. So that's why interaction is shown with Kafka cluster and consumer group, these two only. Now below part you can see it's a zookeeper cluster only because there are multiple zookeepers. Till now we have been using only one zookeeper, but it is always recommended more than one zookeepers so that it will again create a kind of fault tolerance for zookeepers. One zookeeper might go down at any point of time, and then in that case your cluster will be destroyed easily. Okay, so this yellow part in the bottom, that is nothing but the cluster of zookeeper, and this is what we have to set up now, because Kafka cluster we have already set up with 3 brokers, right? Now still we are using one zookeeper, so we will do this thing also. Now let's read something about the zookeeper cluster. Some terms are there which we have to understand before we proceed with zookeeper cluster setup. So zookeeper cluster setup. So zookeeper servers run as a leader follower node. If leader fails, new leader will be elected. Now the basic difference between Kafka cluster means your broker cluster and zookeeper cluster is that in a broker cluster there is no leader and follower. Okay, leader and followers are there just inside the partitions. So one partition will be called leader, one partition will be called follower, or 2 partitions will be called follower, but these nodes are never called follower or leader, correct?
Yes.
These all are same. These all are brokers. We never say this is master, this is slave, or this is leader, this is follower. But in zookeeper, always there will be one node which will be leader, another one will be follower. So that is the basic difference in zookeeper cluster, and will be leader, another one will be follower. So that is the basic difference in zookeeper cluster and Kafka broker cluster, because it works on the concept of leader followers node. Now second thing is cluster of zookeeper server is called ensemble. So this cluster which you see, this is called zookeeper ensemble also. You can call it zookeeper cluster or you can call it zookeeper ensemble.
Okay.
Okay. Third point is there is a formula through which you can identify how many nodes you will create for zookeeper cluster. Okay. So that formula is Q equals to 2n plus 1. Okay. So this will give you how many nodes you need. So this formula is nothing but Q is called quorum. Okay. So this quorum you can figure out. If you want to tolerate one failure, then you give one value here and you will get 2 plus 1, 3. So 3 node zookeeper cluster can tolerate one failure only, one node failure. Okay. Similarly, if you want 2 node failure, then you give value 2 here. So 2 to the 4 and plus 1, 5. We need to create 5 node zookeeper cluster. So 5 node zookeeper cluster can tolerate 2 failures, means 2 nodes go down, still it will survive. Okay, so this is the formula, so this is called the quorum. So quorum is nothing but number of nodes, number of minimum nodes which you require to create a healthy zookeeper cluster. Okay. Okay. If you say 2 zookeepers are there in your Kafka cluster, that is not a that is a Kafka cluster, but that is not providing the quorum. Correct? I'm repeating again. If in your zookeeper cluster only 2 nodes are there, then as per the formula we are not achieving the quorum, because quorum says at least at least 3 nodes should be there. 2 nodes will definitely create the issue. It will not a healthy cluster if you are creating the cluster with 2 nodes, 2 zookeeper nodes. Similarly, if you are creating a Kafka cluster with 3 nodes, again, failure of 2 nodes, right? So this is quorum. You understood the difference between ensemble and quorum? Ensemble means nothing but cluster, Kafka cluster. So it can have any number of nodes. But as per recommendation, your number of nodes should be derived using this formula, which is called quorum. Okay. So this is the thing. Next thing is minimum recommended zookeeper nodes is 3. So that we can derive from this formula only, right? Minimum at least 1 node failure we want to achieve. Okay. 1 node failure. And if we don't want to achieve any kind of failure, just give 0. So 0 to the 0, then only we need 1 node. So nodes will always be odd in a zookeeper cluster. Okay, always create a zookeeper cluster with odd number of nodes with minimum 3 nodes. So you can create a cluster with 3 nodes, 5 nodes, 7 nodes, like that. And so last point says that thing only. Number of nodes should be odd. So this is something very important you need to keep in mind. Anyone asks you what is zookeeper ensemble, you should be able to answer it. Anyone asks what is quorum, you should be able to answer it. Quorum is a term which is generally used in zookeeper cluster only, and it is nothing but it is a healthy state of the ensemble, and it gives the it is a healthy state of the ensemble, and it gives us the count of minimum required nodes.
Yeah.
Okay, now let's go ahead. We discussed in the previous slide that zookeeper servers always work in the leader follower configuration. So here you can see there are 3 servers, 3 boxes are there. Those are 3 servers. Those are 3 zookeeper servers basically. Okay. So we have 3 zookeeper servers, and in the middle of the box you have written the ID of those servers. So first server is being given the ID 1, second one 2, given the ID 1, second one 2, third one 3. Okay. And in the bottom we can see the client. So who will be the client of these zookeeper servers?
Consumers, brokers.
Oh, sorry.
Consumers.
Consumers will be the client, as well as your brokers will also be client, right?
Yeah.
Because in the previous diagram you see here, this is zookeeper cluster. So these are 3 servers, server 1, server 2, server 3. And who will be accessing these zookeepers? Either Kafka brokers will be accessing it, or consumers will be accessing it. Okay. So those are the brokers or consumers. Now, obviously, whenever someone try to access these zookeeper server from the outside, whether it's client, whether it is consumer or broker, which port they will use? 2181, because 2181 is the standard port for zookeeper server. If I want to access any zookeeper server, I will go through port number 2181. But on the same machine, we cannot use same port number for 3 different zookeeper servers. So obviously, we will, for second zookeeper server, we will have to give 2182 port. Third zookeeper, we can give 2183 port. Okay. So using this port only, other clients will access these servers. Till here it is clear?
Yes, yes.
Now,
similar like a broker. We are changing.
yes, very much similar. how we give different 9092, 9093, 9094, same way. Now, the only difference is because we said these zookeepers work on the concept of leader and follower, or we can say master and slave concept they use. So there should be some kind of election technique so that if any node is selected as leader, there should be some way to do the election. So that's why election is done between these three, or it could be 5 also, 7 also. So whatever number of zookeeper servers are there, election is done among them, and one node is selected as leader. The remaining will remain follower. So that election will happen using a port. Okay. So we need one port on each broker server through which election can be done. So you can see one arrow, and that arrow is nothing but a port for leader election. Similarly, on server 2 also there will be one port which will be used for election purpose. Third one, again here will be one port for election purpose. Okay. So this port will be used only for election. After that it will never be used. Okay. Whenever initially when the zookeeper cluster will start, that time election will happen, and to achieve that election we will need this port, and once the election is done, that port will remain idle. We'll never use it. Now there will be one more port required through which all these zookeeper servers can communicate with each other for normal activities, like if they want to share any information among themselves regarding the Kafka broker, and if they want to share the information about the number of topics available in the Kafka cluster. So that the day-to-day information and day-to-day normal regular information, that will be shared using a different port. Okay, so that port is for peer-to-peer communication. So peer is nothing but these servers are called peers to each other. So this server, these are buddies actually, because they will be running in the same cluster. So they are peers of each other. So whenever they want to communicate with each other, we need one more port. So 2 ports are there here on this server also, this server also. So that 2 ports are mentioned here as colon separated numbers. So 288 colon 3888. Okay. So these are the 2 ports. So you can see this 288 port will be used for leader election, and 3888 will be used for peer communication. Similarly here 28889, that will be used for leader election. I think I am telling opposite. So 28888 will be used for peer communication, 388 is used for leader election. And here on this server 2889 will be used for peer-to-peer communication, and 3889 will be used for leader election. Similarly, on the last server 2889 will be used for peer-to-peer communication. 3889, that will be used for leader election. So I think this entire diagram is clear. Jagdish, are you there?
Yes.
Okay. So how many ports are there on each zookeeper server?
2 ports. One for election and one for peer-to-peer communication.
So can you be please louder? Not able to hear you.
There will be 2 ports, like one for leader election and one for peer-to-peer communication.
Okay. Sorry, there will be 3 ports. One port you have missed, 2181. Right?
Yeah, connecting.
2 ports are here. One port is also there. This is also 2181 is the port of this server only. Okay. So there will be total 3 ports. One is for client. This is also 2181 is the port of this server only. Okay. So there will be total 3 ports. One is for client communication. One is for peer-to-peer communication. one is for leader election. So each zookeeper port, each zookeeper server has 3 ports for different purposes. Okay, that you have to keep in mind. Okay, 2181 is the port actually which will be visible to everyone, which will be public. Okay, but these 2 ports which we saw just now, 2888, 3888, 2889, 3889, these are internal ports which will never be visible to you as a client or as a consumer. Okay, or as a broker, Kafka broker. You will not be able to see these ports. Those will be used internally within. So these things you have to keep in mind always. And each zookeeper server will have a ID also. So that ID is written here in the middle. So that ID also you have to you have to assign to each zookeeper whenever you start the zookeeper. Okay. So as we go forward, we will set up this multi-node zookeeper cluster. So now you have the enough information how you will set up it. So first thing is you will assign ID to each the zookeeper server. Second one is you will create a listener port for all the zookeeper servers. So these are the listener ports 2181, 2182, 2183. These ports will be public to all the consumers and brokers. They will be accessing these brokers. They will be accessing the zookeeper cluster using these ports. Okay. Third thing is you have to assign 2 internal ports to each zookeeper node so that they can participate in leader election and they can communicate with other zookeeper node. Okay. So that is the third thing. And obviously log directory we always configure in the zookeeper.property file, so that will also be there. Okay, and so that is the information. Now we will discuss about what are we going to do to set up the zookeeper cluster. Okay, so these are the steps. And so we are going to set up a zookeeper cluster of 3 nodes so that we can achieve quorum also. Quorum says it should be 2n plus 1.
Yeah, 1 for columns.
Yeah. So 3 zookeeper cluster will provide the number of failures 1. Okay. We can only tolerate 1 broker failure using this setup. Okay. Now what you will do is, it is very simple. Till now we have only one zookeeper.property. Now if you want to create 3 zookeepers, then you copy paste the same zookeeper file 3 times. Okay. You can rename it zookeeper1.property, 2.property, 3.property. If you don't want the existing zookeeper.property to rename, don't do it. Then there will be 3 files. One will be zookeeper.properties. You can create like zookeeper1.property. Third one you can create zookeeper2.property. Okay. And if you want to rename all 3 so that avoid any kind of confusion, then you can rename all 3. You can give them name 1, 2, 3. Okay. It is up to you.
Okay.
Like you remember yesterday, one broker file we gave server.property. Second broker we gave server1.property, third we gave server2.property. But sometime it might be confusing who is the broker 1.
Yes.
So you could have renamed to server1.property, server2.property, server3.property. That would have been more clear. Okay. So here that is what we are doing. We are clearly saying who is zookeeper 1, who is 2, who is 3. So we have renamed all 3 properties to the 2 who is 3. So we have renamed all 3 properties to these names. Now, second step is we have to create data directory also for 3 zookeepers. So in the data folder, currently we have one folder called zookeeper. Yeah. Now we will create 3 folders: zookeeper 1, zookeeper 2, zookeeper 3. Okay. So obviously these three folders will be storing the data for three Zookeeper nodes. And third thing is we have to assign the ID also to each Zookeeper. So to assign the ID, we have to simply create a file, and that file name is my ID. So just go inside that above created data folder, Kafka data Zookeeper 1, and inside that create a file called my ID. This is a command to do that. You can do it manually also. Okay, this same thing. So I will tell you when we set up it. So this is the second thing you have to, third step you have to do. Just create my ID file in this Zookeeper folder, and that file will only hold a number, simply, nothing else. Now, after creating this, we have to add these properties. There are few extra properties which you have to add in each Zookeeper.properties file. So one thing is called tick time. So tick time you have to mention as 2000. Second property is init time, that you have to set up as 10. Sync time you have to set up as 5, 10. Sync time you have to set up as 5. Okay, so these three things I will explain later once we will start setting it up. Then if you have the data directory, so this property you are already aware. So here you specify the complete path. So in your case it could be D colon Kafka colon data colon Zookeeper 1. Okay, and then client port for first Zookeeper you can give 2181, second Zookeeper it will become 2182, and 2183 for third one. Okay, maximum client connections. Okay, max client CN XNS. So it is in short form. So maximum client connection you can specify 60 or whatever number you want to give. If you don't want to change how many clients can be connected to this Zookeeper cluster. That particular Zookeeper server. So if you want to allow only 60 clients at a time, then you can give 60. Okay. So if you know that this Zookeeper server doesn't have the capability to support more than 60 connection because RAM is less or processor is not that powerful or other resources are less, then you can give the number of connection accordingly. That is the only purpose of that property. Okay.
Okay.
This 4-letter word, 4LW means 4-letter word. So sometimes there are certain commands which if you execute on for that particular Zookeeper, those will give issues. So we are for that particular Zookeeper, those will give issues. So we are for those 4-letter commands we are whitelisting. So that's why we are giving this 4LW commands whitelisted as star. Okay, this for the time being you can skip. This is not very important property as of now. You can skip. Now, last three properties are nothing but giving the internal ports to each of the Zookeeper node. So for first node, we are writing server.1. Okay, so 1 is the ID of that server. Okay, server.1 equal to localhost, and this is the port for peer communication. This is the port for election. Okay. Similarly, server.2. Okay. Similarly, server.2. 2 is the ID of the second Zookeeper. Then localhost, peer port, election port, and so on. Okay. So these are the properties which you have to change in all the Zookeeper.properties file. Any doubt so far?
the peer-to-peer port is cost different, right? And you said 2 888 2.
Yeah. So see, we are these three things we have to specify in all the zookeeper files, because each zookeeper should be aware of the ports of other zookeeper, right? So I think your question should be why entries in all the zookeeper file, because that zookeeper should also be aware of what are the internal ports of other zookeeper.
Okay.
So that is why. So these are the internal ports of all three zookeepers. That's it, nothing else. And 1, 2, 3, these are the IDs. You can change the IDs to something else if you want to give 101. So give 101 also. That is also fine. No one will stop you. But then in the previous section we saw this my ID file which you will create. There also you give 101 only.
Okay. Got it.
Okay. So this is clear now. This will be the condition of your zookeeper 1.property file. If you follow whatever I told you, so data directory will become this. In your case, it is become this. In your case, it is D colon Kafka data zookeeper 1.
Yes.
So you can change this file. This is client port. Tick time will be 2000 millisecond always.
Okay.
Init time is 5. Sync time is 2. Maximum client connections I have given 0. And then server 1, server 2, server 3 and internal ports. Internal ports could be in this series, 2000 series and 3000 series. Okay. So obviously there are 3 zookeeper. For all the ports, all 3 zookeeper, you cannot keep the same internal ports.
Yeah.
So that's why you have to change the last number. So here it is 6, we have made it 7, it is 8. Here it was 6, so we made it 7.
888 2 that's
Yeah. It's not like this only. We can give anything, but the series will be in 2000 and 3000 only.
okay.
Okay. Number will always be greater than 2000 and 3000. So this zookeeper 1.properties. Similarly, this is zookeeper 2.properties. Okay. Nothing changed here. Same to same. Just we have changed the port number, which will become 2182. Tick time, init time, sync time will remain same, and this last 3 entries will also remain same.
Okay.
And this is zookeeper 3.properties. Now you have to run the zookeeper because everything is set up. You have created the files. You have created the files also here, data directory also. My ID file, don't forget to create because this is very important. Otherwise, your zookeeper will not run. So my ID file you have to create.
Inside my ID, we need to type the number.
Okay, let me show you. So this here, is this clear?
Yes.
Now finally you have to run it. So how you run the zookeeper? The same command. Zookeeper server start and the property name. That's it. One by one you have to open the terminal and start. So now 3 zookeepers are there. So you need 3 different terminals. On they should always be running. You should not close those terminals. Okay, like how we did for Replica.
Yeah.
Okay. Now I was showing you how to do it. So this is my. I was showing you how to do it. So this is my Kafka. If you are able to see my screen.
Yes.
So this is my config. So here you can see I created 3 zookeeper files. Zookeeper 1, 2, 3. Okay. So if I open it, this is the properties which are given here. Okay. This is zookeeper 3. For this, I give this. This is zookeeper 2. So this is fine now. My ID file I was telling you. So this is the data folder. I created 3 folders here. Zookeeper 1, 2, 3. Okay. Now if I go inside zookeeper 1, this is the file I created. There is no extension also given to this file. You will see only 1 is written in the inside this, because this is for zookeeper 1. So 1 is mentioned here. Now if I go to data zookeeper 2, here also I have my ID file. If I open it, 2 is mentioned here. And for data zookeeper 3 also I have given 3. So my ID is the name of the file and you have to give this value. And this ID only we are using here. If you see this 1, 2, 3, these are nothing but the ID. But if I gave here, suppose 101, 102, and 103. These are the IDs. So then, and 103. These are the IDs. So then, in that case, you have to give like this. Clear?
Okay.
So that's it, nothing else. I hope it is clear to you. Any questions?
No, the port number only we can directly give which port number.
Port number I have given you, right? This, you can use this kind of port number. And this is client port number which you have to change to 2181. So second thing will become 2183, 2182. And these ports 6, 3666, here also it is 2666, 3666. So same thing you need to copy in all files. Okay.
So we can also give the same port number 2666, 6768, 3666, 6768.
Yes.
Okay.
Alright. So in the next class we will do the practical. We will set up this cluster. Okay. Meanwhile, you go through this PPT, try to digest it.
Okay. We'll try to create the zookeeper cluster. We'll try to create the zookeeper cluster.
Yeah, you can try it. Whatever steps I have mentioned, if you follow them, you will be able to.
Okay.
Alright. Okay, Jagdish, then we'll meet on Monday.
Okay, Sapang, yeah.
Revise everything. On Monday, I can take you through some questions. Okay, kind of an interview. So you read everything. Okay. This I take occasionally because otherwise people don't pay serious attention to each and every fundamental. So you go through it and I'll ask questions.